Okay, so new trigonometry
Recording
thing. And in this case, what I'm going to do is I'm giving you information about the sides of the triangle. And I'm not telling you anything about the angle. Okay? But let's say you're walking up some kind of ramp or something, and you measure the distance that you walk as 15 meters.
Mm-hmm.
And then you also measure how high up you are at the end, and you decide that's 5 meters.
Okay.
But you don't know the angle. How can I write down the trig function that involves these two sides and this mystery angle? What would I write down? Leaving the angle as a variable. With this angle, which of the three sides does this side represent?
Which of the three sides?
It's either opposite, adjacent, or hypotenuse. This side is which of those three?
The opposite.
Opposite. Okay, so the opposite is 5. Which side is this?
The hypotenuse.
Right. Hypotenuse is 15. Okay, so opposite and hypotenuse join forces to make which trig thing?
So.
Okay, so what is that? Which
Sine.
function? Sine, okay. So sine of theta equals 5 over 15, same as 1/3. Okay?
Mm-hmm.
This is another way of expressing this angle, right? I could tell you to go out and get a 15-meter piece of wood, which is a pretty long piece of wood, and a 5-meter piece of wood.
Just a fair size.
Right. And if I prop up the 15-meter piece of wood with the 5-meter piece of wood,
You'll get that triangle.
we'll get this triangle and we'll get this angle. We don't know what the degree measure of the angle is.
But we know we'll get it.
But we know that, I mean, this is one way to instruct someone how to build that angle, right?
Mm-hmm.
So the question is, how do we use the calculator to get the answer? So on the calculator, there should be above each of sine, cosine, and tangent.
I was using it.
They were, so you were using those?
Yeah.
For what?
I didn't know what they were. I was using them later on.
So we're going to see what they were.
Oh, I was using it here.
Okay. Oh, perfect, actually. So you did do it a little bit.
I didn't know what they were. I was using them, though.
So, well, they are kind of just a calculator function that tells you the answer. So what we're saying is that if sine theta equals 1/3, now I'm going to use space.
Space?
I'm leaving space for what I'm about to do. What we would want to do in our mind is like divide by sine. Okay, so if we could just divide by sine, we could solve for theta. Of course, that's ridiculous because sine is not a number.
Yeah.
Sine is a function. Sine is like a thing that comes along and
helps you.
Talks to theta and produces a number. So that part is sloppiness. We can't do that. But we do have notation that makes us think about dividing, and I'll show it to you like this. How do I solve 2x equals 10?
2x is equal to 10. Well, you divide by 2.
Okay, what if I told you instead I'm going to write it as I multiply by 1/2?
You do that too.
Same thing. Okay, 1/2 you can write as 2 to the minus 1.
Mm-hmm.
Agreed?
Yes.
Okay, so that is why when we use the inverse functions, we write them like that. So I'm going to take sine inverse of sine of theta, and that is, so I'm doing that to both sides of the equation, okay? Sine inverse and sine we can think of them as canceling in the same way that we think of 2 inverse and 2 as canceling.
Okay.
Okay? So that explains why I would use that notation.
Okay.
Okay? Because it's like we want to divide by sign, but we can't really do that, so we write this new thing out, sine of -1. Okay, sine of -1 cancels with sine, that leaves theta. And then now all we do is just put this into a calculator, because there's no way to do this other than to just look it up in a calculator. Okay. It's not like I can get out and do some square roots or something and come out with the angle. Okay? So you can think of inverse sine. What it does is inverse sine tells you, what's the answer? Uh-oh. So we got 19.47 degrees. Okay. 19.47. Inverse sine tells you the angle. In the event that you don't know the angle, all you can do is measure the sides.
Okay.
Okay. And then, so we could do a similar thing with inverse cosine, inverse tangent. So, what's the situation where you might want to know tangent? Well, what if I started here and then I walked, we'll call it 10 meters. I walked 10 meters and then I climbed a ladder or something. We'll call that, what? How far does that look like? About 3 meters? I climb a ladder 3 meters. And then what I do then is I look down. So I'm up here and I'm looking. And I want to know what this angle is. Just as vocabulary, this angle down here would be called the angle of elevation.
Okay.
And it's the same as this angle right here, which we would call the angle of depression. So my question is, having gone this route of walking 10 meters and then taking an elevator 3 meters, what is the angle produced? Well, tangent of that angle is 3/10, right? So if I have a calculator, I can do this. I can do tangent inverse of both sides, and I get that the angle is tangent inverse of 3/10. And what is that, according to the calculator? Tangent inverse of 3/10.
No, so like tangent inverse of 3.
What happened? Oh, there we go.
They got
16.7. Okay? All right, so inverse tangent and inverse sine and then inverse cosine is how you trade what you could call, I measure this like with a ruler, right? I can measure these sides with a ruler, and using inverse tangent, I can get an answer that I would need a protractor for. Does that make sense?
Yes.
Okay.